Welcome to Algebra 1, Chapter 8, Section 2, Factoring using a greatest common factor. Our goal here is to factor polynomials. So what does it mean to factor? Well, it means to break it into simpler parts. So factoring a polynomial means to rewrite the polynomial as a product of simpler parts. The factored form of 6, for example, is 3 times 2. A factor is a whole number or variable that divides into another whole number with the remainder 0. So we're going to see which one of these that x cubed is not a factor. Well, x to the fifth. Well, x to the fifth is x cubed times x squared. Since x cubed is in the product, it is one of the factors. In this one, if we simplify it, we have x2 plus 1, y, which is x cubed times y. So in that one, x cubed is one of the factors. Here we have 3 cubed, which is 9. And then we have x squared, which is x to the fourth. Of course, that equals 9 times x cubed times x. So that x cubed is a factor of that as well. So 12x squared is the only one it's not a factor of. Circle the factor tree that shows the prime factorization. So we want to look for the tree that is factored completely. Well, 6 could become 2 times 3, and x squared could be x times x. So at this point, it's factored completely, but the step where it's left, it is not. This would become 2 times 3 times x times x. Now it's factored completely, but previously it was not. This becomes 2 times x, 3 times x. And the last one is already factored completely, so it is done, and that is our answer. One way to factor a polynomial is by using the greatest common factor. To find the greatest common factor for our polynomials, we want to find the largest factor that goes evenly into both of the monomials. Let's look at a pair of integers to see if we can work our way through this. The greatest common factor of 4. Well, 4 and 5 is not it. 4 and 6 have a greatest common factor of 2. 8 and 12. That 4 is the largest factor that goes evenly into both 8 and 12. 8 and 16, that's not it because the greatest common factor is 8. Now when you're dealing with variables, you need to look at both the integer, or the coefficient, the 4, and the variable, in this case the x. So the 4 doesn't go into the first one. Again, the second one has a greatest common factor of 3. The third one, does 4x go into both 8x and 12x? Yes. Is it the largest factor of both 8x and 12x? Yes, it is. And although 4x goes into 8x and 16x, it's not the largest factor. In problem 8, we're going to cross out the pairs of numbers whose greatest common factor is not 6. So 6 is not the greatest common factor there, nor is it here, but it is here and it is here. Likewise, as soon as you add 6y squared, these are still not a product of something that has 6, or 6y squared in this case, a factor of it. This does, and this does as well. So when looking at a polynomial, in this case a trinomial, and we want to find the greatest common factor of all the terms, first look at the coefficients. So find the greatest common factor of 3, 9, and 12. The largest factor that will go into 3 evenly, 9 evenly, and 12 evenly is 3. Now, what's the greatest common factor of x, x squared, and x to the fourth? Well, it's x. X is the only one that will go in there evenly. So the greatest common factor of this trinomial is 3x. When determining the greatest common factor, it can be a little difficult. One way to make it a bit simpler might be using a factor tree. Looking at 9x to the 6, we can factor out a 3x, and that 3x will become 3 times x. Well, when you factored out the 3x, the other side was 3x to the fifth. That became 3x, which became 3 times x, to the x to the fourth. X to the fourth became x times x cubed, which became x times x squared, which became x times x. So for 9x to the 6, we had 3 times 3. That's where we got the 9 from. X, 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 x. So that's the factorization of 9 x to the 6th. Let's look at 15x to the 4th. Again, we're going to factor out the 3x, so it's 3x times 5x cubed. 3x became 3 times x. 5x cubed became 5x times x squared, which became x times x. So factor version of this is 3 times 5 times x times x times x times x. Let's look at 12x squared. That became 2x times 6x. 2x became 2 times x. 6x became 3x times 2. 3x became 3 times x. So we have 2 times 3 times 2 times x times x. Now, when dealing with these for the greatest common factor, we're going to see more about this in the next slide, you want to look for like terms. What do they have? What do they all have? Well, they all have a 3. So that's one of the factors of the greatest common factor. They all have 2 x's. So it's x times x. So 3x squared is going to be the greatest common factor. See here I've written down that we had 0 common factors of 2. The 12 had a 2 factor, but nothing else did. They all had a factor of 3. Only the 15 had a factor of 5, but they all have 2 factors of x. So as you saw, we had a 3 times x for our greatest common factor. To write this in factored form, we need to first add like terms. Well, in this case, there's nothing to do that time. Factor the greatest common factor from each term. So I need to take 3x squared out of each term. Take 3x squared out of this term, and you're going to end up with 3x to the 4th. Take 3x squared out of this term, and you're going to end up with a positive 5x squared. Take 3x squared out of this term, and you'll end up with a positive 4. And that's the factored version. Factoring using a greatest common factor, you are going to 1, identify the greatest common factor. 2, divide the greatest common factor out from each of the terms, and then write the factored version as a product. To factor this polynomial, I need to first come up with the greatest common factor. What goes into 9, 3, and 6? Yes, the greatest common factor there is 3. Now let's look at our variables. The first one has a variable of x squared, the second x, but the third is a constant. There is no variable there. So hence, I don't have a variable that is a factor of each term. So my greatest common factor is simply 3. So I'm going to pull a 3 out. So look at this, 9x squared divided by 3 is going to be 3x squared. Then I have 3x divided by 3 is going to be x. And then I have my constant 6 divided by 3. Well, 6 divided by 3 is 2. So I factored that polynomial. Polynomial has some variables. So let's determine the greatest common factor to be able to factor that out. First, look at 16 and 12. What is the greatest common factor of 16 and 12? What goes into both 16 evenly and 12 evenly? And it's the highest number that goes into both. Did you say 4? You would be right. Now we have an a squared and an a. Well, that would be a. A goes into both a squared evenly and a evenly. And then we have a b cubed and a b to the 4th. So that would be b cubed. So we're going to pull that outside using parentheses, and then we're going to divide that out of each term. 16 divided by 4 is 4. A squared divided by a is a. And b cubed divided by b cubed is 1. Then we have 12, negative 12 divided by 4. Well, negative 12 divided by 4 is negative 3. A divided by a, well, that's 1. B to the 4th divided by b cubed is b. So we've just factored this polynomial by removing the greatest common factor. Here's another trinomial that we are being asked to factor. In this case, we have no factor of the coefficients. There is no greatest common factor that goes into 2, 5, and 8. Nor is there any greatest common factor of x, y. So in this case, there is no greatest common factor. So at this point, we cannot factor this any further. A landing pad or a helipad is sometimes marked with a circle inside a square, so it is visible from the air. In this example, we want to determine the area of the region that's outside the circle but inside the square of the helipad at the right. Write your answers in factored form. So our area of the square is going to be 6x squared because it's length times width. It's a square. It's a type of rectangle. The area of the circle is pi r squared, so it's 3x squared. It's the area of the squared, the 6x squared, minus the area of the circle, 3 pi squared. In the previous slide, the original equation was 6x squared minus pi times 3x squared. So this was 36x squared minus 9 pi x squared. Because remember, you have to multiply everything inside when you multiply it. So my x squared can be factored out because it's in both cases. There's an x squared in this term and in this term, so it can be factored out. So I'm going to have 36 minus 9 pi times x squared. Well, what goes into 36 and 9? Well, 9 does. So I can factor 9 out of that as well. So I'm going to take 9x squared out of 36, which would be 4, and 9x squared out of 9 pi, which would be pi. So the factored form of the shaded region is 9x squared times 4 minus pi.